sine of theta over cosine of theta equals tangent of theta. Alright, so we need to show or prove that somehow, right? So consider the fact that these trigonometric functions, we have theta here, this is the opposite side, this is the adjacent side, and this is the hypotenuse, and so we say that sine of theta is equal to the opposite over the hypotenuse, cosine of theta is equal to the adjacent over the hypotenuse, and then again tangent represents the opposite over the adjacent, right? We know that for sure, right? We're good with that?
Yes.
Alright, so if that's the case, then sine so let me write this a little differently. Then this would be sine of theta, right?
Can't see that.
Of course.
Can I turn off the light?
No.
Alright.
How about that?
Yes.
Okay, that's sine of theta. And then this would be cosine of theta. Okay. And then this would be tangent of theta. Now I'm doing this on purpose, and then I'll go back over it with a black marker so you can see it better. Okay. So sine of theta is opposite over the hypotenuse, right? Cosine of theta is adjacent over the hypotenuse, right? And we're stating that those are equal to tangent, which is going to be the opposite over the adjacent. So my question to you is when you take a fraction and you divide it by a fraction, what's another way to address that? Multiply the reciprocal, which will give you all of those things are equal to the opposite over the adjacent, correct? What happens to my hypotenuse? They cancel out. Is that statement true?
Oh, this is sweet.
Most people don't know that.
No, we do.
I do. Okay, good question. That's one of two questions. So let me stop recording.